Okay, so now we're back for example 3 of exponential functions on page 51, and we're right down here at the bottom. Mrs. Klimperer, let's get right on it. It says Mrs. Klimperer told her English class that each week students tend to forget 1/6 of the vocabulary words they learned the previous week. This already sounds different because we're forgetting, so that sounds like we're losing. In the examples before, waste was increasing and the biology cells were increasing, but in this one, it says that we're forgetting. So that means that this is a different type of exponential function, which we'll look at in just a minute. Ms. Klimper, it says, suppose student learns 60 words. 60. That is at the beginning. At the beginning, you know 60 words. Look where 60 is in this equation. All right. The number of words remembered can be described by the function w of x equals 60 times 5/6 to the x power, where x is the number of weeks, sounds like time, that pass. How many words will the student remember after 3 weeks? So we have a graph, and we have a table. We're going to put our equation in Desmos and see how that table generates. But just think, at the beginning, at the start is time 0. And how many do we know at the beginning? 60. And what are we doing? Well, we're forgetting. Why? Well, we're not in school, so we're forgetting all our vocab, right? That's why we have to bring it back up. We forget the things that we learn in algebra because we got this new stuff coming on. And then we have to go back and remind ourselves about what we've learned to keep it fresh. All right, so let's come over to Desmos, and we will type this equation in. And I already have y, so here's equals, and my equation is 60, so 60, and then parentheses, 5/6. So 5/6 is a fraction. How do you type it in? Well, you're going to say 5 and then the slash that's on your keyboard underneath the question mark, 5 divided by, look at there, set up a fraction, 6. And now you'll notice where the cursor is. It's still in the denominator. I need to get that out. So if I put the parentheses up right away, look where it put it. Yeah, that's not where I want it. I want it over here. So let me delete that. And then I'm going to hit the space bar. Nope. I'm going to hit the arrow key. So the right arrow key. Aha. Now it's where I want it. So now close the parentheses. And then do you remember where your exponent is? Shift 6. And now I'm going to put in x. All right. So 60 times 5/6 to the x power. And let's look at this graph. Wow, it's in green this time. And it seems to be going the other way. The graphs that we looked at before started over here and went way up like that. But this one, let's zoom out, appears to be starting up at the top and coming down and flattening out on the right side. I wonder what that means. I bet it means something. All right. So we want to see our table. And if you remember how we get to table, we're going to take this gear. So we're going to click gear and convert to table. And there are our values. And I might need to see some more. So I'm going to hit 3. And then I'm going to come down and hit 4. And then I'm going to hit 5. Let me look over here. 1, 2, 3, 4, 5. Oops, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I don't need those negative numbers. So I'm going to scroll up a little bit, and I'm going to hit 6, and then 7, and then 8. And you see, I can find those values. Oh, come on, I'm going to do 9. 10. Wow. All right. So what I want you to do is to just kind of press pause and fill in those values, right? And I'm going to do the same. So let me press pause, maybe. Let's see. Whoop. So I tried to fill it in and then come back to you, and it erased it. So we'll try to get the values put in right quick. Let's do that. We've got number of weeks. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we already looked at the graph to know what's happening. So in the very first, at the very beginning, how many vocabulary words did we know? 60, right? So you can go back and look at your table. I also have it on my calculator. You can look at it on Desmos and pull off those values. After the first week, what? We only knew 50 words. And then after 2 weeks, we knew, well, it's decimal, so we'll have to start rounding, 42. And then after that, it was 35. And then by week four, we only knew 29 words. Wow, we're forgetting. I mean, a lot. By week, uh, by week 5, it says we know 24. By week 6, it says we know 20. By week 7, it's 17. Let me scroll down and look. Let's see. Week 8 is about 14. Week 9 is 12. It's 11.6, but we got a round because you don't have 0.6 of a word. Where are we? Week 10. Week 10, we'll say, is 10. And by week 11, we know 8. Wow. So you can see, like if this were the course of the summer, if you knew lots of vocabulary at the end of May, and then you all June and July until you got back in August and started with vocabulary again, how many would you know? Not very many. Sad. So, what's happening? Well, as x is increasing, this time y is decreasing. And where it says how many words will the student remember after 3 weeks? Well, after 3 weeks, we're only going to know 35 words. Could we graph that? Well, we could. Let's see. 0, and this looks like what, 10, 20, 30, 40, 50, 60. That's kind of hard to see, but there's a point. And then after 1 week, we only know 50. And then we can put some more points in here. After 2 weeks, we know about 42, so up right there, just a smidge. At 3 weeks, we know about 35, right? So let's come on out here and jump. Let's see. After 10 weeks, we only know 10 words. That's pretty scary. 8, 9, 10, 10, 10. So you can see what's happening. And then eventually, because we looked at the Desmos graph, it's going to come down here and flatten out. All right, so 8 weeks, we knew 14. And that's kind of what it's doing. It's doing that if we wanted to connect this. And then off the graph, what's it going to do? Eventually, it's going to come down here and flatten out. And it's going to approach 0, right? What does this side do? Well, we don't have negative time, but this side, if we did, is doing what? It's going up like this. And there's our exponential curve. What's different about it? This time, instead of growing, it's what we call decaying. And so for the next example, we're going to celebrate learning a pattern and a model, not y equals mx plus b, that's a line, not y equals ax squared plus bx plus c, that's a quadratic. But on page 52, we're going to look at the parent function form of an exponential. So I'm going to stop this, and you fill in your notes.